So when we have solutions, we need to quantify how much solute is in the solvent. And we do this by looking at the concentration. Okay, so concentration is basically where we express the amount of chemicals that are in a solution. And generally speaking, this will be expressed in molarity. There are a lot of other different units, but in this class, we really don't use them. Molarity is a capital M. Do not use a lowercase m to represent it because that's something completely different. And molarity is the moles of the chemical in a liter of solution. So what that means is you will often see a capital M equals moles over liters to represent molarity. And this is a really convenient way to use the molarity triangle as well. So remember, we had the density triangle. It works the same way here. If I'm solving for molarity, I cover up the capital M. It gives me moles over liters. If I'm solving for moles, cover it up, molarity times liters. Solving for liters, cover it up, moles divided by molarity. The only other things that you guys might see is you may have to convert grams to moles, and you do that by dividing by the molar mass. Or you may be asked for the grams, and you would have to solve for moles first, then convert to grams by multiplying by the molar mass. I would also keep in mind that if you have 123 milliliters and you're asked to have a volume in liters to do the calculation, don't bother showing me the one-step metric conversion. Move the decimal 3 places to the left. That would be 0.123 liters. Okay? All right. Now, let's take a look at what we can do with molarity. Since molarity is a fraction unit, you can use molarity to obviously convert between one unit or the other. Can I move this down? We have this. Okay, so if you take a look down at the bottom here, they're showing you, they're showing you that if you've got 3 molar HCN, that means it's 3 moles of HCN in a liter of solution. So this equivalency statement could be written as a fraction depending upon our needs to cancel out moles or liters. So it would either be 3 moles over a liter or 1 liter over 3 moles. Okay, so the way that you read this is 1.8 mole HCl means 1.8 moles of HCl in a liter of solution. They may also say 1.8 molar HCl, okay? And let's turn to the next page. And we're going to do some practice problems, okay? This should be pretty straightforward for you guys. Now, on the next page, they do give you a little diagram of how to convert between moles and liters with what fraction. The molarity triangle does that for you as well. So if we take a look at these practice problems right here, and it says we've got 0.72 liters of 2.5 molar NaOH. We want to know how many moles of NaOH we would solve for. Well, if you take a look back at the molarity triangle, if you cover up moles, it says take molarity times liters. So 2.5 molarity times 0.72 liters will give us moles. And you want 2 sig figs because that's the fewest that we have. You're going to end up with 1.8 moles. Okay, we could have also written molarity out in moles per liter, and that would show you that 2.5 moles over 1 liter, which is the same thing as molarity, times 0.72 liters, that will cancel liters, and that's how we get moles. Okay? Okay, for number 2, it says we've got an IV bag of saline, 0.154 molar HCl, or NaCl. How many moles of NaCl does 500 milliliters contain? Do not bother showing me the one-step conversion for milliliters to liters. Move the decimal 3 places to the left. That's how you get 0.5 liters. Again, you are simply multiplying molarity times liters, and then that will give you moles. And then you would want 3 sig figs. So this will end up being 0.0770. The 0 on the end is required. That's the only way you can get it to have 3 sig figs. Okay? You try number 3. Let's see what you come up with. I got 5.0 liters. Okay. Okay. I want to do number 4 with you just because sometimes they give you some interesting units and I just want to make sure it doesn't throw you off. Okay. So number 4 says a person's urine may have a distinct odor as soon as 15 minutes after eating asparagus. Methanethiol, one of the metabolic products responsible for the odor, can be detected by some people in concentrations as low as 4 times 10 to the negative 8th molarity. At this concentration, what volume of urine contains a millimole of methanethiol? Okay, so we need to convert millimoles into moles so that we can then use molarity to help us calculate liters. So what I would do is I would set this up so that you're converting millimoles into moles. This is similar to a one-step metric conversion. Put the number 1 where the milli is, put the power of 10 on the other side, so these would cancel. And that's how you get this 1 times 10 to the negative 3 moles. And then when you're solving for liters, you know to cover up the L, and that's moles divided by molarity. So this divided by molarity is going to give you your liters. So this is going to be 2.5 times 10 to the 4th liters. Okay? Okay. Now let's talk about actually making a solution. And this is something that I'd like to do with you today. I'm not sure we'll have time to get to it. It doesn't take very long. Okay? All right. Making a solution is a skill that is kind of required in chemistry, okay? So that means you would often be asked to make a certain molar solution, and that means that you need to understand how to do the calculations and then what glassware to use. So can I move the screen? Yeah. So down here, they explain to you in words, and they do a problem on how to actually make a solution. So a solution of known concentration is called a standard solution, okay? And to prepare a 1 molar sodium chloride solution, you need to measure out, since 1 molar is the same thing as 1 mole of NaCl in a liter of water. That means technically you would need to measure out a mole of sodium chloride. Now, you cannot measure a mole out on the scale because mole is not one of the units on the scale, but grams is. So that means you have to determine how much a mole of sodium chloride is in grams, okay? And if you were writing to me how to do a lab on paper, you would absolutely have to tell me how many grams you're measuring out, not how many moles, okay? So the way that you do this is you would calculate it, and you know that the molar mass of this is the grams in a mole of sodium chloride. So what you're doing is you're adding up sodium, which is 22.99, with chlorine, which is 35.45, and that will give you these grams that you have to measure out on the scale, okay? Okay, then what you do is you add water up to, I'm emphasizing the up to, and the reason is because you often need to dissolve that solid in a little bit of water first, because the volume will rise. If you just add water, if you add a liter, it will end up being more than a liter because that solid is going to make the volume expand. Does that make sense? Okay, so always add water up to the point where you need to go. Don't just add it all at once. And that's because here it says the solute, which is the salt or the ionic compound that you measured out, will displace a small amount of water. That means the water is going to rise. Okay? Okay, so let's go over how to do this. Let's take a look at the sample problem. Can I move the board down a little bit? Okay. So in the sample problem, it says describe, and I will definitely ask you to do this. If it's not on a test, it will be in a lab or both. Okay? So it says describe how to prepare 0.055 liters of 0.2 molar KCl from the solid. So the first thing you have to do is you have to figure out how much you have to measure out. So remember, this 0.2 molar is the same thing as 0.2 moles of KCl in 1 liter. right? So what you have to do is figure out how many grams that is, right? So if you recall, I have my molarity triangle, okay? And if I've got a volume and I've got a molarity, then I can figure out moles and I can convert moles to grams. So you would take your molarity times liters to get moles, and then you would convert that over to grams by using the molar mass. So this right here is your molarity times your liters, and then this is the molar mass of KCl. So the amount that you have to measure out is here, this 0.82. So then you would need to give me a sentence explaining that. You would say, measure out 0.82 grams of KCl. You've got to tell me what the substance is, so give me the chemical formula. And then you would say, add water up to whatever the volume is that I'm asking for. Make sure you say up to. Otherwise, it shows that you don't fully understand how to make a solution. Okay? All right, let's turn to the next page. I'm going to have you do number 1 in the practice problems. Let's see what you guys come up with. Okay. All right. What did you decide? You can just walk me through it.
So, like, you want the equation or just sentence?
Tell me the math.
Okay, so 0.5 liters of solution
Yeah.
times 1.5 moles of CaCl2 over 1 liter of solution. Wait.
I see what you're saying.
Yeah.
Okay.
Times 110.98 grams of CaCl2 over 1 mole of CaCl2 equals 83 grams of CaCl2.
82?
83, sorry.
Okay, then what did you say as like a sentence?
We said measured out 83 grams of CaCl2
Okay.
and add water up to 500.0 milliliters of solution.
Yep.
0.5.
0.5, yes.
500 mils or 0.5. Okay. Perfect. Done. We good? Agreed? Okay. We're not going to do number 2. But I would like to take a look at number 3 before I move on to the next part. Okay, so number 3 wants to know what the molar concentration is of silver nitrate. They measured out 1.8 and they added water to 75 mils. So all they're telling you here is that you've got to convert your grams to moles. And silver nitrate is AgNO3. So that means you have to divide by the molar mass to convert your grams to moles. And your molar mass is 169.88. It's pretty big. And then you're going to end up with 0.011 moles of silver nitrate. Divide that by, move the decimal 3 places to the left, 0.075 liters. This will give you your molar concentration. I got 0.14. I think depending upon your rounding, you're either going to get 0.14 or 0.15. But you get the general idea of how there's an extra step in there because you weren't given moles to begin with, you were given grams. I got to stop